Welcome back, students, to the class of friction problems. We'll continue with the previous problem. We were with the problem on the ladder friction, which was describing about the two unknowns, that is the horizontal force required to avoid the slip of the ladder. And the second condition is, if I don't apply any horizontal force as P, what should be the angle of inclination? Okay. So if I recall back, this is the problem what we are discussing in the last section. So coming to the second part of the unknown, to find the value of theta such that there should not be any slip. Okay, we'll draw the free body diagram of the ladder, So we'll take the same ladder as A and B, the points A and B. A is referring to the ground point, B is referring to the point at the wall, and this is the ladder you find, and you find a load of 1000. A man is standing at point B. You find this is 1000 Newton, and you find one more person as 200 who's standing at the center of 2 meter distance from A point and 2 meter distance from B point. And if possible, when the ladder slips, you have to remember this, the ladder that will slip down the wall in this direction, the motion of the wall will be in this direction, and the motion of the ladder in the ground level, at the ground level, will be to the left side. Okay, so keeping that in mind, we have to drop the friction direction. The friction direction will be opposite. I'll erase this quantity so that there will not be any confusion. So the friction will be here. I call it as FW, and this will be NW. And here the friction will be FG and NG. Correct? Now I have to calculate what is theta. Theta is the unknown quantity we have to calculate. So that is what we told here, to calculate what is the angle required to avoid the slip of the ladder if the person continues to stand. Okay, if the person continues to stand. So again, we have to draw the equations, write the equations of equilibrium. We have the equations of equilibrium as apply equations of equilibrium, right? Taking sigma h is equal to 0. Take it as positive right and negative in the opposite direction. Okay, so I'll take all the horizontal forces. So plus FG. Okay, then you find minus NW. Am I correct? Yes, minus NW. Is anything else you find here? Any other force is equal to 0. Fg, I can write it as mu g into Ng minus Nw is equal to 0. What is the value of Ug and Fg, Nw? We have the values. We have the separate values. The coefficient of friction values are separate. Here it is given. The friction with respect to wall and the ladder is 0.25. So mu W is 0.25. So mu W is 0.25. And mu G is 0.35. Mu G is 0.35. So I'll take these values. So 0.35 Ng minus Nw is equal to 0. I'll block this equation. Give the equation number as 1. So further, I can apply the next equation of equilibrium, sigma v is equal to 0 plus upwards minus downwards, right? If I remember, I am correct. Ng plus Ng, right? Then you find plus Fw, correct? Yes, plus Ng plus Fw minus 200 minus 1000, the load, minus 1000 minus 200 equals to 0, or Ng plus Uw into Nw minus 1200 is equal to 0. Uw is 0.25, so Ng plus 0.25 Nw is equal to 1200. So I'll block this answer and call it as equation 2. Okay, then now I'll go with third equation of equilibrium, sigma moment at any point. I'll take it as point A as equal to 0. Okay, so the point A, I'll read out the diagram once again here instead of scrolling up and down again and again. This is the motion, the Fw, Fg, this will be Ng, and the slip will be taking down the wall. So Fw will be up the wall, and this is Nw, and theta here, 200 here, 1000 here, correct? This is 2 meters and 2 meters. So now I'll take the point A, this is point A and this is point B, right? I'll take the moment of all the forces. Okay, first I'll understand point A is here. Fg will pass through point A, Ng will pass through point A. So these forces will be 0. 200, how it is causing a moment? It is causing a clockwise moment. Okay, what is the perpendicular distance? So this is the perpendicular distance. So what is this distance? You can take it as, what can be this distance? It is 2 cos theta, right? And next 1000, how it is moving? It is moving clockwise. Okay, what is the perpendicular distance? This is a perpendicular distance. So 4 cos theta, because cos theta is equal to adjacent by hypotenuse, right? So adjacent distance, I get it as cos theta into 4, right? Or 2, right? Similarly, Fw, how it is moving? Anti-clockwise. What is the perpendicular distance? This is the perpendicular distance. If I draw for you, I better understand this is the perpendicular distance. Nw, how it is moving? It is moving anti-clockwise. So for Nw, this is the perpendicular distance. This is the perpendicular distance, which will be 4 sine theta. Okay, now I'll write the equation. So 200 plus 200 into, I'll write it as 2 cos theta, correct? Plus 1000, 4 cos theta, correct? Then I'll take the moment of Fw. Fw minus Fw into 4 cos theta, then minus Nw 4 sine theta. Anything else you find equals to 0. So if I submit and all that, do it once again, I can get it as 400 cos theta plus 4000 cos theta minus 4 Fw cos theta, correct? Minus 4 Nw sin theta equals to 0. That is how you get it here also. Right, you get it here also, the same value. Fine. So now upon substituting, I can take the common here as cos theta. Cos theta, I can take it common. 400 plus 4000 minus 4 FW, and take this on the other side, 4 NW sin theta. Okay. Now I can take it as sin theta by cos theta will be equal to what? I should get down this here, 400 plus 4000 minus 4 FW divided by 4 NW. So I can write it as 4400 minus 4 into NW into mu W into NW divided by 4 NW. So tan theta is equal to, do we have any value here in the of NW we get? Yes, because solving equation 1 and 2, upon solving here, solving equation 1 and 2, we get the value of NW and NG. Okay, we get the value of NW. Taking this value, substitute here in the unknown places and get the value as theta is equal to, we get it as theta is equal to 68.95. 68.95 degree. So this is the angle. We have to place the ladder such that the angle will, the slip of the ladder doesn't take place. Okay, students? With this, I'll end the session. Thank you all.